Hello, this is Daniel Moscow. My project involves visualizing some aspects of electricity consumption and production in the United States. This website pulls data from the US Energy Information Administration, which collects, analyzes, and disseminates information on energy in the United States, and in particular, the interactions between energy, the economy, and the environment. On the first tab, a user can explore a state's seasonal pattern of electricity consumption and how consumption over a particular time period compares to a long-run seasonal pattern. Selecting New York from 2019 through the most recent available data, we can see the actual retail sales of electricity in red compared to the first and third quartiles shaded in dark gray, and the all-time maximum and minimum for a month shaded in light gray. We can see, for example, that throughout 2019, electricity consumption in New York was generally within its normal seasonal range, near or within the dark gray region. Zooming in on 2020 shows electricity consumption generally below its normal range and near an all-time monthly minimum for May 2020. This graph also makes it easy to see differences in seasonal consumption patterns across states. For example, New York shows strong peaks in consumption in the summer months and smaller peaks when it's coldest. By contrast, Arizona shows a very high peak in the summer and comparatively little consumption during the cooler months. The second graph on this tab shows the mix of fuels used to generate electricity within a state. Both graphs adjust to show the same time period, so comparisons can be made between fuel mix and electricity consumption. Looking at Iowa and selecting coal, natural gas, wind, and nuclear for the period 2015 to 2021 shows how electricity production within the state has changed during that time. Notice that Iowa shut down its sole nuclear plant in September 2020. This is shown by the disappearing purple band at the bottom right of the plot. A growing share of electricity generation in Iowa has been due to wind. This is shown by the overall increasing thickness of the green band. However, when demand is highest during the summer months, some share of production transfers from wind to coal. The second tab shows how states vary in energy intensity, which is the ratio of energy consumed in a state to its total economic output. This plot allows the user to compare energy intensity in a group of states to those states' GDP over time. The bubbles at the end of each path show relative population change within the state. Selecting New York for the period 2015 to 2019, we can see that GDP increased steadily because the path moved steadily from left to right, and energy intensity showed an overall downward trend. That means that for every dollar of GDP that's being produced, less energy is being consumed over time. However, for the period 2017 to 2018, there was a slight increase in energy intensity. Let's select Louisiana for the period 2003 to 2010. For the period 2003 to 2005, GDP increased steadily and energy intensity decreased. Hurricane Katrina marks a sharp turning point for Louisiana, beginning a period of decline in GDP as the path moves back toward the left and increased energy intensity as the path moves up. After 2007, the state returned to a trajectory of progress with slowly increasing GDP and decreasing energy intensity. We can also plot the paths of several states together. Selecting California, Florida, New York, and Texas for the period 2001 to 2019. These states represent the largest economies in the US. All 4 states show steady overall increasing GDP and declining energy intensity. New York alone shows no discernible increase in population over this period, as shown by the bubbles at the endpoints for New York being roughly the same size in both places. The economy of Texas is much more energy intensive than that of other states with similar GDP. And all 4 states show a temporary reversal of trend around 2008. We could see this by zooming in on the time around 2008. So you can see the backward track in California and these other little hiccups. Thanks for watching this presentation. Hopefully, if you choose to explore this site further, you'll take away something new about how states produce and consume electricity and how states' energy usage and its overall economy are related. Thanks.